Right, we're going to be looking at question 1. And looking at question 1, we're going to be one point 1.1. Okay, we're looking at x squared minus 4x plus 3 equals 0. X and x. What are the factors of 3, for example? Okay, we're just recapping on basic notions. So here it's minus 3 minus 1, correct? Okay, so and then x is 3 or x is 1. Okay, these are very basic. And we are looking at this paper. Connected to decimal places, you're supposed to solve 5x squared minus 5x plus 1 equals 0 to 2 decimal places. Then we start by saying x equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. Minus, what is b? Is minus 5 plus or minus. Okay, the b is minus 5, you square it, minus 4, the a is 5, and the c is 1 all over twice a. Okay, what is our a? Um,
5.
our a is exactly 5. Thank you so much. Okay, this is very, very easy. Okay, if you simplify all these, I know that you understand this, it gets down to plus or minus the square root of 5 all divided by 10. Okay, so now when we solve this, you then will have 5 plus the square root of 5 out of 10. So x is 5 minus the square root of 5 out of 10. Right, so we're able to get this one here. And then what are the answers here, which means therefore x here. So use a calculator for this. I know that this is not difficult at all, but I'm just recapping so that you actually can get a feel of some of the basics here. And therefore you do this one here. And when you do this one, the 5 plus is going to be 0.72 approximately. So this one, 0.28. Those are the two answers for we have solved 1.1.2 for to 2 decimal places there. Okay, so we continue. One point 3. Okay, so for purposes of the exam, it's very important that you're able to also deal with. Well, we're moving to functions quickly. Okay, want to deal with the factors of this. What are the factors of this? So the factors of this would be greater than 0. This factors of x squared are x and x. Factors of minus 10 are minus 5 and what? And plus 2, right? So in which case, therefore, you would have the critical values, right? So the critical values are x5 and x equal to minus 2. In which case, you're going to use two methods. This is the usual because it's positive, or it has a smiley face, right? So there's smiley face, and then, or if you don't do this, if you do this, or you're going to use the number line to do this, so you're going to use this for the number line. Then you have x here, this is x here. Okay, so at this point, you'll put minus 2 there, you'll put 5 there. You'll put minus 2 there, you'll put 5 there. Right, so because this is greater than 0, where is this graph greater than 0? Okay, so you analyze that and realize that this graph is greater than 0 here, when it's above, is greater than 0 when it's above. Right, from this shape, the smiley face, we're going to see that x is smaller than -2 or x is bigger than 5. Or if you don't want to do that, you can use a completely different method and use the number line. The number line, therefore, where is this greater than 0? Okay, this number line will therefore demonstrate that it is going to have a couple of signs here. Like you're going to have, it's going to be positive there, and it's going to be positive there, and it's going to be negative there. How do you see these signs? So these signs, you just pick random numbers, a number bigger than 5, you plug it into the equation. A number bigger than 5, you plug it into the equation. So how do we do this? Right, you would say let x be 7, because the number 7 is bigger than 5. And then you take x minus 5 and into x plus 2. You plug in the 7 minus 5, 7 plus 2, which is 2 times 9, which is what? Which is 18. And 18 is a positive number. You do that here, you're going to get a positive and so on. Get a positive there, and etc. So I've already put the signs in circles at the bottom of the number line. So which means therefore this is going to be greater than 0 here. Well, interested in what is positive, so we're going to move in that direction of the positives. The positives, we can see the, or actually, yes, please. All right, yeah, okay, that's fine. I'll see you in 1 minute now. Okay, 1 minute. Please come again. All right, yeah, that's 1 minute now. Okay, right. So in this case also, you would see that x is less than -2 or x is bigger than 5. Okay, so in which case, therefore, these answers are the same. So you can use either the smiley face, or you can use which is the shape of the parabola, or you can use the what? You can use the number line there. Okay, there are many ways to do this. Right. So if you look at, so this one is done. Now, if you look at, yes, please. All right. I'll be with you just now. Let me just, so we're trying now 1.4. You're gonna give me the answers in 1 minute. Just try it there in 1 minute, and then I'm coming back now. Brazilian, Brazilian, please come quickly. You need 50 rand. Yes, my dear. Yeah, thank you, my dear. Siyaphila njani, my dear? Siyabonga kakhulu. Usithokozisa ka-stress. Angithi because sijwayele ngathi wetsangi, akhona ukuphefumula, that. Yeah, that's the thing. So, but it's about our bigger now. All right, yeah. All right, thank you, my dear. Thank you, my dear. Hello, Waruna.
Yes, sir.
Yes, sorry, you're still here. My apologies, because I just went off a minute and
What's
there
up?
was somebody needed my attention. All right, now if you look at the next thing, here, this one, right. So this one is very, very easy, right? So you look at this, which is 3, the square root of x is equal to x minus 4. Okay, that's a given question. We need to solve for x. Right, to solve for x at this point, we need to just square both sides. So we square the left. I'm just recapping on some of these basics. So I'm going to give you a full paper to practice, to try, and then you will submit to me the attempt. You square the 3, you get 9, and you square the square root, you get x. Right, so here you use the FOIL method, because the x minus 4, you can write it like that. Okay, let me just expand this. So you square the x. X by -4 is -4. X by 2, which is -8x, plus what? plus 16. So this is x squared minus 17x plus 16 is equal to 0. Okay, so in which case, therefore, you continue to factorize these. What are the factors of minus 16 or plus 16 that give minus 17? They are minus 16 minus 1. So x is 16 or x is 1. Right, so now which one is the solution? We check the solution. We check x equals 16. We must check the left hand side. Because we every time after squaring both sides, you must check the answers. So you check the 3 the square root of x, you check 3 the square root of 16. What is the square root of 16? Is 4. 3 by 4 is 12. Now you check the right hand side. I'm just sharing some of the skills here on our exam mastery. So obviously this one here you have for the 16. Okay, so you put 16 minus 4. What is 16 minus 4? Is 12. Okay, so in other words, 16 is okay. Okay, but we're not done yet. We're also going to check x equals what? 1. For x equals 1, we're going to check the left-hand side. The left-hand side is 3 to the square root of x. 3 to the square root of 1 is 3. The right-hand side is x minus 4. What is x minus 4, for example? Right, so here it is going to be x minus 4, which is 1 minus 4. 1 minus 4 is minus what? Is minus 3. Okay, but obviously you can see that here is minus 3 and 3. And then you can see that this one is not applicable. So this one is not applicable, and the only applicable is that one. So the one that is not applicable is also referred to as inadmissible. So in other words, that one is not applicable, and the terminology we use, we can refer to that as inadmissible. Okay, you can say it is inadmissible. That one. Okay, so we're done with that one. So we move on to 1.2. Let's practice some simultaneous equations after this. Okay, right. So how do we deal with simultaneous equations and how to solve equations simultaneously? We're going to begin by looking at the two equations and make sure that we understand the simultaneous equations here and be in a position to solve this. And so we have 3x minus y equals 2, and then you have 2y plus 9x squared equals minus 1. All right, so what is this? You can easily solve this, but you just make y the subject in one of the equations. So we're going to make y the subject in the first equation. Right, in the first equation. Right, looking at, for instance, the first equation, you make y the subject. So moving y to the other side and moving 2 to the other side is going to be y equals 3x minus 2, and then it is 3. So what you do is you put 3 into equation 2. Right, so if that is the case, then you have 2 into 3x minus 2 plus 9x squared equals minus 1. So this is exactly 6x minus 4 plus 9x squared is equal to minus 1. What is this? Well, this is exactly 9x squared plus 6x minus 3 equals 0. Divide through by 3, and then you get 3x squared, and here divide by 3, you get 2. Divide by 3, we have minus 1. Right, so this is what we get. Right, so we get the factors of this. What are the factors of this? of 3x squared, we know that 3x and x, and the factors here are 1, 1. You put minus plus, from which you're able to see that x is 1/3 or x is minus 1. Okay, now we use the other equation, equation 3, so using equation 3. All right, equation 3 is the equation that says y is equal to 3x minus 2. You plug in the 1/3, so is you put 1/3 here. You put 1/3 here minus 2. You put minus 1 minus 2. So here you multiply through by the 3, it becomes 1 minus 2, which is minus 1. Okay, here you put minus 3 minus 2, and it's minus 5. Right, so these are the answers. These are the answers. So what are the two answers? All right, so the two answers are the following. So this is the answer for x, and this is the answer for another x, and this is the answer for y, and this is also the value of y. Okay, the next thing we're going to do is to look at to solve 1.3. And 1.3 now, we are dealing with something that is very, very important for us to focus on. Right, in 1.3, we are looking at the this particular equation here. And we are dealing with two equations, and we need to solve. Okay, let's see what we are getting here. Right, so in 1.3, 1.3, right, so in 1.3 we have the following. Right, we have that these two equations. You need to calculate without the use of a calculator the expression there. All right, now let's continue with this. But we have a little trick there, okay? Because now you need to convert the 3 to the 9x to something, right? So you need to just be a little bit creative, okay? You need to be a little bit creative. So let us do this. Right, we have been given 3 to the 9x, which equal to, which equals 64. So you have 3 to the 3x. You raise it to 3 equals 4 to the 3. Oh, 3 to the 3x is equal to 4. Okay, so we have these results. And the next thing is we're going to have another result. What is the result? Okay, this is P is equal to 64. And then now you can write these differently. So you can be able to take the square root. Right, so you can be able to take the square root of these. Right. So in other words, if this is true, what else can this be? So now you can decide to apply the square root both left and right. So you'd have the square root of 64, and here you can have the square root of 5 um, with a p like this. Okay, so the square root um, can do what I've done here. Okay, what is the square root of 64? We know it's 8, and this is the square root of 5, and this one is the square root of p. Okay, right. Now, what is this? We're in business now. We just need to simplify what has been given to us. Okay, what has been given to us. And so it follows therefore that we can write in a different color. We can choose blue. So this is the following: 3 x minus 1 square root of 5, and then you raise square root of p. Square root of 5 is square root of p. Okay, what is this now? So this one you can write as 3 to the power 3x minus 3. You divide everything by The square root of 5 square root of b. Ah, which is 3 to the power 3x. You divide everything by 27. Square root of b. So you stop. What does this? What is 3 to the power 3x? It is 4. And then we have that you have 27 here. What is 5? The square root of 5 and that. The square root of 5 and that is the same as what? The square root of 5 and that is the same as 8. The square root of 5 raised to the power p is the same as 8. You simplify everything here, and the result is 1 over 54. And this is what they wanted. 1 over 54. 1 over 54. 1 over so that is the result. Okay. Right. So the next thing now we're gonna proceed and do and solve more problems. And so we continue to solve um, the next question. Right. Then to solve the next question. Let's continue. Right. So here we're doing a question 2. Is your load shedding at 10? Do you know?
I've already had my load shedding.
You have already had it.
Yes.
Okay. Right, because I need to check. I'm suspecting that mine is going to be a 10. Just anyway, obviously we're still way far from that, but just need to know. Right, obviously we're looking at question 2 now. I'm just looking at, I think that it will happen at 10, so that I'm prepared before the time. I can just, because I can either skim beyond that and to discuss a couple of more things. Yeah, because it's gonna be from 10 to 12 midnight. Okay, that's fine. We are aware. Right, so let's continue and solve more problems now. So looking at question 2 now. Yes. Okay, given the quadratic sequence, this one, write down the next term of the sequence. Okay, write down the next term of the sequence. What is the next term? Right, so we're going to start with this because it's a quadratic sequence. We can easily write the terms. Okay, so you have 2, you have 3, you have 10, you have 23. Okay, what is the difference here? Is 1, here it's 7, there is 13. What is the difference here? 7 minus 1 is 6. There's the 13 minus 7 is 6 as well. Okay. So you know that the second difference will be 6. And then if you add 13 plus 6 gives what? Gives 19. Right. And so 19 plus 23 is what? It's exactly 42. Okay, so the term is 42. Next term. Next term is 42. Okay, so you have this. Right, determine the nth term of the sequence. Right, what is the nth term of the sequence? So it's easy. We start by saying 2a is equal to 6. Okay, if 2a equals 6, we divide both left and right by 2 and we get 3. The next thing is we say 3a plus b is equal to, so 3a plus b must be equal to this here. So we say that 3a plus b is equal to 1. Okay, so if 3 plus b, but a you already know a is 3 plus b equals 1, which means b is what? Which means b is minus 8. Okay, and then now the next thing is the following. Right, so we say a plus b for the quadratic sequence. A plus b plus c is equal to 2, the first term of the quadratic sequence. We already know that a is 3, b is minus 8 equals 2. And then when you continue here, what do we achieve? Right, we're able to see that this is c equals. What is 3 minus 8 is minus 5, and then you add, it is equal to 7. So, what is the nth term of the sequence? So, the nth term of the sequence is given by the following. Right, so the nth term of the sequence is given by Tn, which is equal to, well, the formula is that an squared plus bn plus c. So, which means Tn is a. What is a? 3. And squared the b is that, and the c is 7. Okay, so this one is the nth term of the sequence. All right. So to test the fact that the nth term is correct, you can generate the original sequence again by replacing n by 1, and you get the first term 2, and n by 2, you get 3, and so on. Okay, calculate the 20th term of the sequence. Right, so now in 2.1.3, you need to calculate the 20th term of the sequence. So now, which is 3 into 20 squared minus 820 plus 7, which is T20. Use a calculator here. This is going to be 1047. So which means the 20th term is exactly 1047. Right, so we look at the next one, which is 2.2. Given the arithmetic sequence, this one, calculate which term of the sequence will have the value that. Right, so we have an arithmetic sequence. What is the arithmetic sequence? It is 35, it is 28, and it is 21. All right, so that's what we're getting, and this is the arithmetic sequence. Right, if this is the arithmetic sequence, we can be able to get the difference. Okay, what is 28 minus 35? We can see that it is minus 7. And then if you say 21 minus 28, we can see it is minus 7, which means the common difference is exactly minus 7. The first term of the sequence is 35. So which means therefore Tn is a plus n minus 1 into the common difference d. Tn equals, what is the first term? It is 35 plus n minus 1 into the common difference d, which is minus 7. So Tn is 35 minus 7 that plus that. So which means this is minus 7n plus 42. Right, so calculate which term of the sequence will have the value this. So now you are saying you have minus 7n plus 42. You see, this term is going to have the value minus 140, which is minus 182. Okay, you transpose the minus 42, and then now you divide it through by minus 7, and the result is exactly 26. So they said calculate which term of the sequence will have the value minus 140. So the term of the sequence that will have that value is exactly 26 there. Term number 26 will have the value minus 140. 2.3. Right, so you continue to look at 2.3. For which value of n will the sum of the first n terms of the quadratic sequence in question 2.2 be equal to the nth term of the quadratic sequence in question 2.1? Yeah, for which value of n will the sum of the first n terms of the arithmetic sequence in 2.2? All right, so we are looking at the value of n for which the sum of the first n terms of the arithmetic sequence in question 2.2, which is this one, will be equal to the nth term of the quadratic sequence in question 2.1. Okay, so that's easy. So you're just equating the two there. But now note that you are dealing with the arithmetic case, right? So and you're dealing with the sums. Okay, right. So what do we do? First, we need to realize that for which value of n will the sum of the first n terms of the arithmetic sequence. So now we are dealing with the arithmetic sequence and the first n terms. So one way to deal with the arithmetic sequence, if you know already um, the nth term of the arithmetic sequence, so we will say this one is n over 2 into a plus l. So now what is this? Okay, the first term is 35 minus, what is the last term? Is minus 7n plus 42. Okay, so this is Sn equals, okay, use the last term formula. So it is exactly n over 2 into, and then here you have minus 7n, and then you have plus 77. Okay, we go on and on. All right, if you distribute here, you'd have minus this one over 2 plus 77 and over 2, which means it is minus that over 2 plus 77 and over 2, which means it is 3n squared minus 8n plus 7. Okay, you add everything here, and this is exactly 13n squared minus 93n plus 14 is equal to 0. So you have n minus 7, and then you have 13n minus 2, which means n equals 7 or n equals 2 over 13. Okay, so this is not applicable. Yes, my dear. All right, my dear. Which one? All right, that's fine, my dear. Yes, yes. Oh, all right, my dear. All right, my dear. Okay, so I'm right back now. Just speaking to someone. So we are going on with the discussion, and we are solving more problems. So they said for which value of n will the sum of the first n terms. So we determined the sum of the first n terms, and now we are saying here is the sum of the first n terms. Um, we will such that it will be equal to the nth term of the quadratic. So we have the nth term of the quadratic. This is the nth term of the quadratic, and the sum is equal to the nth term of the quadratic. And we determined that obviously this is not applicable because the number of terms cannot be 2 over 13. The number of terms, if we say count the number of people, by and large, the number of people must be a whole number. You might say the number of people in the class, number of learners in the class is 7. So there are 7 learners in the class, and that's what we need to say. So we do not just um, get a fraction and say there are 2 over 13 learners in the class. We do not normally have that kind of a situation. Right. Okay. You can hear me, right? Okay.
Yes, yes, I can hear you.
Okay. Thank you. Because I need to confirm sometimes. Okay. Because now when I check the recording, I need to just make sure that, because if you can hear me, then it means the sound is being recorded, because sometimes you might not really be able to know if there's something wrong. Maybe the sound is not going through. Okay, here we're given a geometric what? A geometric series we has a constant ratio, 1/2, and the sum to infinity is 6. Right. Calculate the first term of the series. Right. So let's find the first term of the series here. Very, very, very straightforward. Right. We've been given that the constant ratio is is actually 1/2, and the sum to infinity is 6, which means the sum to infinity is that. Right. So the sum to infinity is that. What is the first term? 1, and the common ratio is that. So what is this? Well, you can write it like this here. 1 minus 1/2 is 1/2. Okay, you multiply it through here and you get this, which means A is what? A is 3. So we have A is 3. Right, so now calculate the first term of this series. Okay, now here you need to calculate the eighth term of this series. What is the eighth term of this series? Right, so now we found the first term. The first term is A, and we found that the first term is 3, using the sum to infinity formula. Now, in the next one, we're looking at 3.2. Right, in 3.2, calculate the eighth term of the series. And right, that's what we want, the eighth term of the series. So the eighth term of the series, we use the formula AR to the n minus 1. So we are interested in the eighth term. But we know very well that the first term is what? The first term is 3. We've already got that. The constant ratio is 1/2, and it is raised to, right, 8 minus 1. So which means T8 is 3 into 1/2 to the 7th power. Okay, we use a calculator to do the rest of this, which means now T8 is this. What is this? Is exactly 3 over 128. That's the answer. Okay. Um, right. So, um, right. So, which means that the eighth term is 3 out of 128. All right. So we continue and we look at the next thing. Right. So we're gonna look at the 3.3. Given this summation, calculate the value of n. What do we do? Right, we've given this series and need to find the value of n. And how do we go about this? Right, let's get started. So this would be the sum to n terms. So you have the sum to n terms. And then the sum to n terms is 3 into 2 raised to 1 minus k, which is 5,18, 5,8125. All right, so let's do this now. So we do the substitution, we expand this summation, which has been given in sigma notation. If you put k equals 1, this is going to be 3 into that, 1 minus 1. 3 into 2, you have 1 minus 2. Yes, 1 minus 2. And then you have 1 minus 3. Okay, which is 5,8125. This is exactly 3 plus 3 over 2. Plus 3 over 4 plus dot 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 equals 5,8125. Right, so you can find the geometric sum to n terms. Right, we have written this summation out and then we can find the summation. Okay, the geometric series formula says that here you have 1 minus r to the n and you divide it by 1 minus r, and this is exactly the same as 5,8125. Right, so this we substitute everything. What is the first term? Well, the first term can be clearly seen in the original, and this is the first term. So the first term is 3 into 1 minus, right, what is the common ratio? So the common ratio is 1/2, and you raise it to the power n divided by 1 minus 1/2, which is 5,8125. Right, so we're gonna 1 minus 1/2 in the denominator would be half. You multiply 2 by the 3 by the 2 that is going to come from the half in the denominator, giving us 6. Okay, 1 minus 1/2. Yeah, okay, and this is this 5,8125. Right, so what is this? Right, so this is that. Right, so this is 1 over 32. Right, so if you simplify everything, you divide through by 6, you make a 1/2 to the power n, the subject of the equation. This is what you get. You can remove this. So that you write the following and say, right, it is exactly that there. Okay, okay. And then this can be written as 2 to the minus n is 2 to the minus 5, which clearly means n equals 5 here. Alternatively, you can use the log. Okay, if you use the log, it is n the log of 1/2 equals the log of 132. So this is 5. Right, so you see that this is the case. Okay, so you see that n equals what? N equals 5. All right, so let's continue and do the next one. Um, we found we defined the value of n, and you can see that the value of n is n equals 5. Right, so now here we do this one. If this summation is p, write down these in terms of p for 3 marks. So we're looking at 3.4. So here you have 20 into the sum of k equals 1. K equals p. Okay, so right, you have been given that this equals p. Write down these in terms of p, this summation in terms of okay, we have been given that these equals p. So which means that this one we have already expanded it from the previous question. It became 3 plus 3 over 2 from the previous question. When k is 1 in the beginning, it becomes 3. When k is 2, it becomes 3 over 2. When k is 3, it becomes 3/4. And then we add everything. And then we have 3, 2. And then when 20, we have minus 19. So now you have the summation here, which means you have 24. This one. We have 24 2 to the minus k. Okay, that's the one they gave. right? You substitute k equals 1, it gives 12. When k equals 2, you divide 24 by 4, and that gives 6. When k is 3, you have 3 plus, and then you have 24, which is 2 to the minus 20. Which is 3 plus, you factor out 4, and then you have 3 over 2, and then you have 3 over 4, and then you have 3 times, and then you have 2 to the minus 19. Okay. So you can see that the 3 here, 3 plus 3 over 2 plus 3 quarters plus dot 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 plus 3 to the power minus 19 is equal to p. So this is exactly 4p. Right. So we've written the summation in terms of p. So the conclusion can therefore be, if one wishes to, you can write it as follows. And then say this summation here, okay, this finite sum is a finite series, and it is 24 to the minus k. This is equal to 4p. We've written this sum and sigma notation in terms of p. All right, we're recapping on some of this, and now maybe we get to something interesting a little bit. To you, what we call the graphs and functions, but we're looking at inverse functions in the fourth question. Okay. Right, 4.1. Okay, so let's read the question to familiarize ourselves with the question. In the diagram below, the graph of f of x equals x squared is drawn in the interval x less equal to 0. Yes, please. You can hear me, right?
Yes, sir.
Okay, thank you. Right. So the graph of the f inverse, right? So the graph of the f inverse is given. Here it is, and the graph of f is that one is also drawn. You have p with the coordinates minus 6 and minus 12 is a point on f. Right, so on the function f, you have the point p, and r is a point on the inverse there. Okay. Right, so is f inverse a function? Motivate your answer. Is f inverse a function? F inverse is this one. Now we're asking the question, is it a function? Well, the answer is yes. Why? You can say that for every x value, there is only one corresponding y value. Y value. Right, and or you can say alternatively, it is a one-to-one mapping. One-to-one mapping, or you can say the vertical line test. Okay, it is the vertical line test such that any vertical line cut it once. If the vertical line, any vertical line cuts a graph only once, then we say that function is a one-to-one mapping, or it actually passes the vertical line, right? The vertical line test.
Okay.
Yes, so if it passes the vertical line test, then it means that it is a function. So yes, we have a function there. So the f inverse is a function. Let's look at the next question. Right, in the next question, is R a reflection of P in the line, or if R is the reflection of P in the line y equals x, write down the coordinates of R. All right, let's look at that one. Right, so if you look at 4.2, Right, so let me just clean up a little bit here. This has become too untidy and too many markings on it. All right, so we're asking the question, if R is a reflection of P, okay, here is P, right, but now we're saying another point R is a reflection of P in the line Y equals X. Right, so now this is very, very interesting. Write down the coordinates of R. Right, so the coordinates of R will be very easy. Reflections in the line Y equals X, they just switch their coordinates. So now you'd have the coordinates. You have the coordinates of P, which are -6 and -12. And then the coordinates of R is -12 minus what? -12 minus 6 there. So you just switch around the coordinates of P to obtain the reflection in the line Y equals X. The line Y equals X. Okay, now let's continue. And we look at the next question. Right, and obviously the next thing is we're going to be focusing on 4.3. Calculate the value of A, 4.3. We're looking at the value of A. Okay, what is the value of A? Right, so the value of A can be obtained with ease because we have the function um, a point on F. We have a point on F because this is F. And then we have the point there. So you can use that point to find the value there. Right, so now we write the answer as follows. F of X is AX squared. Substitute -6 minus 12. Okay, -6 minus 12 is X and Y. Okay, so we good. So, which means that at this point, you have that your y is -12 and your x is -6 and you square that. Right, so which is -12. You square the 6, you get a 36, which means it's -12 over 36, which is -1/3. Right, so 4.3, calculate the value of A is that. Write down the equation of F inverse in the form y equals something. 4.4. Right, so the equation of F inverse in the form that. So we're going to start by saying the graph of F. This is how you deal with finding the inverses all the time in metric. So you're going to be looking at this in the trial. So F, the graph of F is what? Okay, we've already seen the graph of F because we've already found A, and the graph of F is what? It is y equals ax squared. So A is -1/3 x squared. Now, if you have something you need, what is the inverse? Right, so the inverse is this one here. It is x -1/3 y squared. So you have y squared -3x. So which means y is plus or minus the square root of -3x. Okay, so you make y the subject of the equation. But obviously, this one is on the negative side because x is negative there. So which means, therefore, we're going to choose only, we're going to say only y is the negative square root. And x is less equal to 0. Okay, x is less equal to 0. Now let's continue. So we have written the graph of the inverse in the form y equals something, and we have answered the question. Right, the next thing is we look at another question on graphs and functions. Question 5. Let's look at 5.1. Write down the domain of this f of x. Write down the domain of f. Right, so to write down the domain here, we say the domain of this function, it always contains real numbers. X is an element of real numbers, but x is not 1 because that you just x is not 1. You say x minus 1, the denominator is not 0. And then this means that x is not 1. So the domain contains all x, which are elements of the set of real numbers, such that x is not 1. If we don't want to say that for the domain, you can say x is an element of the interval minus infinity to 1, union 1 to infinity. Right. So union 1 to infinity. That's what you get. Right, so we found the domain. The next question is we want to write down the asymptotes of f. What are the asymptotes of f? So the every rectangular every hyperbola has two asymptotes. Let's look at this one, 5.2. Right, if the function f of x is minus 1 divided by what? Divided by x minus 1. The asymptotes come from the bottom. So for the vertical asymptote, right, the vertical asymptote, and then you have the horizontal asymptote. Right, the horizontal asymptote. The vertical asymptote will be, you take the denominator and say x minus 1 equals 0, which means x is 1. For the other one, the horizontal asymptote, you take y equals 0. This one, y equals 0. So you have y equals 1. Okay, now we have this. Okay, so we have the horizontal, the vertical asymptote x equals 1, the horizontal asymptote y equals 0. Okay, because there's no constant here, so y is 0. 5.3, sketch a graph of f, clearly showing all the intercepts with axis and any asymptotes. Let's look at that one. 5.3. Sketch a graph of f, clearly showing all intercepts with axis and any asymptotes. Okay, let's continue with this one. Easy. Right, so you're gonna draw the vertical axis and then the horizontal axis. The vertical is called y and the horizontal is called what? It's called the x-axis. We've already seen that the vertical asymptote is what? The vertical asymptote is x equal to 1. So now we're gonna just put that one and say x is 1 there. Okay, need to just make a dash line that is not so untidy. All right, so but it is through x equals 1. And then the other one is y equals 0. So y equals 0 is the x-axis. The equation, the line whose equation is y equals 0 is the x-axis. So this one is y equals 0, is the x-axis. So negative, you need intercept with the axis. Right, so you need to find the x-intercept here, or at least the y-intercept. Okay, let's find the y-intercept. Let's find the y-intercept. Right. Right. So the y-intercept. Okay, what is the y-intercept? You can make x0. Okay, so now you have f of x, which equals to -1 divided by x minus 1. So this is 0, which is minus 0 minus 1, which is 1. So you have 1. Right, so this is the graph is going to do this. Graph is going to do this. If the graph does that, the other one is going to be on the other side. Right, it's not going to touch the asymptote which is there. So it's just going to be here like this. So these graphs are always that way. So there's something to note here. It is the fact that at this point, if you have a hyperbola graph that's a divided by x minus p plus q, the plus q is normal outside, right? Plus q like this. If the number a is positive in the numerator, then it means that your graph is going to be what? It's going to be on the positive and like this. Otherwise, your graph is going to be here and there, where a is negative. A negative is the number on top, but obviously here we can see that a is -1. So a is -1, automatically we know that the graph is going to be in the second quadrant and the fourth. If this quadrant here is the first, the second, the third, and the fourth quadrants. All right, so we have sketched this showing all intercepts with the axis. We have shown there's only one intercept with the axis because the student can try to find the x-intercept. Okay. Um, how do you find the x-intercept? To find the x-intercept, you can try to do that, but you will see that it's not there. Okay, this is just extra. If the student says, okay, what is the x-intercept of f? What will they get? So you let y be 0, which is -1. When y is 0, you have this. You cross multiply and you have 0 is equal to -1. This is not true because 0 is not equal to -1. So it means that this graph, because of this graph has no x-intercept. Okay. So let's sketch a graph showing clearly the intercept axis and any asymptotes. For which values of x will this be greater or equal to 0? 5.4. For which values of x will this be greater or equal to 0? Right, for each values of x will this be greater or equal to 0? Let's look at this question. It's a very interesting one. So now we are saying here x times the first derivative of f is greater or equal to 0. Right, a very interesting question, but slightly tricky, so you need to be very careful here. A couple of things you need to remember. You need to look at the slope of this function because f prime relates to the gradient of the function. But now, at the back of the mind, you need to realize that this is going to cut at 1 like this. Okay, so what do you need here? What do you need? Right, it's going to cut 3 at 1. But we're saying here we're multiplying two numbers. So, and you're getting a positive. So you must have a positive multiplied by a positive to get a greater equal to 0, or you must have a negative times another negative to have a greater equal to 0. At least greater than 0. Okay, the signs must be the same. Now, so let's continue. What do we have? So, what do we have? We have the following. So, so you must have that x is positive. In the first case, you must have that x is positive. So x is positive here. Okay, you must have that x is positive there, but also the slope is positive. Right. So where is that the case? So in other words, we can see that it's when x is greater or equal to 0, because immediately when we move like this, x is positive everywhere, and the slope is going, the function is sloping up. Okay, but also here the function is also sloping up. So in other words, x must be greater or equal to 0, but not 1. Right, so there are a couple of ways to write this one. Okay, or another student can say the slope is critical to 0 when 0 is critical to x. So 0 to 1 union 1 to infinity. So you can also say 0 to 1 included, but 1 is at an asymptote. So it is such that the function itself is what? Is undefined. Okay, so we continue. So we continue. Right. Now let's look at the next question. 5 point question 6. Right, so question 6 is very interesting and easy. Right, question 6. The diagram below, in the diagram below, you have A and B. Are the intercepts of the graph of f and the straight line G through A cuts f at C and the y-axis at 0, 1. M is a point on f. Where is M now? N is a point on G. Here is N on the function G, such that Mn is parallel to the y-axis. Okay, Mn is actually parallel to the y-axis. Right, Mn cuts the x-axis at T. There it is. So you have question 6. Right, you have 6.1. Show that g of x is equal to x plus 1. Show that g of x is equal to x plus 1. Right, let's look at this one. Very easy. How do you show that? Well, you need to find just the slope of this. So you can find the slope of g, the g function. So you can take the 2 points on g, this point and that one. So you can have like this. Right, so the point 1 is 0, 1, 4, 5. So x1, y1, x2, y2. So the gradient is y2 minus y1 over x2 minus x1. What is y2? It is 5. y1, 1. x2 is 4. x1 is 0. What is 5 minus 1? It's exactly 4. 4 is 1. Okay. Meaning that m is 1, but c is the y-intercept, so c is already 1. So you can use the equation that says mx plus c, because m is 1 by x, the c is 1, and therefore the equation is x plus 1. Right. So the equation is y equals x plus 1. Right, calculate the coordinates of A and B. Store these all the intercepts with x's, so you can easily find the x-intercepts there of this one of the parabola function whose equation is there. So that's very easy, 6.2. Right, so in 6.2 now you find the x-intercepts. Right, so if you find the x-intercepts, how do you find the x-intercepts? You let y be 0. So this is x squared minus 2x minus 3 equals 0. Because of x squared at x and x, this is minus 3 plus 1, which means x is 3, so x is minus 1. So which means A has coordinates minus 1, 0, B has coordinates 3 and 0. Okay, so now so you have 6.3. Okay. Now in 6.3 you have you need to determine the range of f. Right, you determine the range of f. So to find the range of f, there are a couple of things you need to look into. You already know that the coordinates are minus 1 and 0 of A, and the coordinates of B are 3 and 0. And the graph of the function, the equation um, of the function is x squared minus 2x minus 3, which is minus b over 2a, which is minus into minus 2 over 2, 1. Q over 2 is 1. So if x equals 1, so we just need to get the y value for that. So which means you get y at f at 1. Can even use a different color for that. Which means f at 1, which is 1 squared minus 2 into 1 minus 3, which is 1 minus 5, which is minus 4. What is the range if at this point here you have that x is 1, because we are dealing with the range is associated with the turning point of the function here. Sorry, x is 1 and y is minus 4. So now we are beginning from here and we're going up. So which means therefore at this point we say that y must be greater or equal to minus 4. What is
Where
6.4?
does the -4 come from?
Okay, that's a good question. The minus 4 comes from the y value because we found f at the value of the function f at 1. Right, we remember that the function itself has the equation, the function f has the equation what? It has the equation, this one here. It is the equation x squared minus 2x minus 3. But we substitute the x value of the turning point, substituting 1 into this. So we substitute 1 into that. And obviously, we substitute 1 into f of x, which is equal to what? X squared minus 2x minus 3. If we plug in x equal to 1, we have 1 squared minus 2 times 1 minus 3, and we get minus 4. So this is the turning point of the function. So the function is going to start from the turning point and go up, right? So how do you say it's going to start from the turning point? We say it is y is equal to minus 4 at the turning point, but it goes higher. So it's greater or equal to minus 4. This y is greater because it goes higher, but it is equal to minus 4 at the turning point. So there are two things. So y is equal to minus 4 at the turning point, but it's greater because the function goes greater. It goes higher and higher and higher. It goes to infinity. Right, so that's what you can say. And this gives us the what? This gives us the range. If you don't give the range like this, how how else do you state the range? So, so you can also say y is an element of the interval from minus 4 to what? To infinity. Um, so yeah. You say from minus 4 and then you go to infinity. Right, you put a round bracket like that. So it's another way of writing. Either you write the red one or the black one. They just agree with each other. Now let's look at 6.4 now, because you are saying here if mn is 6, determine the length of OT. Okay, the length of OT. If t lies on the negative x-axis, show all your working. 6.4.1. Okay, if mn is 6, determine the length of OT. If t lies on the negative x-axis, show all your working. Okay, let's look at this one quickly. Written too many things. Let me just tidy it up, tidy the diagram up a little bit. If mn is 6, determine the length of OT. Here is O and here is T. Determine the length of OT if T lies on the negative x-axis. Here is T. It is on the negative x-axis because x is negative this side, but x is positive this side. Show all your working. Right. So this is easy. A little trick. So you need to realize that at this in this question, you're interested in mn. So mn. So mn is going to be the difference between the two functions. Or we say that mn is going to be the upper curve minus the lower curve. What is the upper curve? X squared minus 2x minus 3. What is lower curve? It's the straight line graph. It's the lower curve. The straight line graph is the lower curve, and it's sitting at x plus 1. Which is x squared minus 3x minus 4. Right, we already said that mn is 6 units, so the difference between these ones is 6, must be 6. Yonto, this is x squared minus 3x minus 4. And then we have x squared minus 3x minus 10. Which means 0 is what? And then here you have x and x. And then you have minus 5 plus 2. Which means x is 5 or x is minus 2. Right, so what is OT now? OT. So obviously, right, it means that OT is 2 or OT is 5. Right. So we can see therefore that the OT equals 5 is not applicable. Is not applicable. The OT equals 5 is not applicable, and therefore OT can only be 2 units. Only 2 units. Well, 2 units because we know the coordinates of A are -1 and 0. And therefore this is just a little bit extra, so it is at -2, making OT 2 units. Making OT 2 units. All right. Okay, now hence write down the coordinates of N. Okay. Right. Hence write down the coordinates of N. Let's look at 6.5.2. Right, what are the coordinates of N? Right, so the coordinates of N right now are straightforward. We know that N lies on the line y equals x plus 1, and we're going to substitute x equals 2. Right, -2. Going to substitute x equals -2 because that's what it is. So you have y equals x is -2 and y is -1. That's the answer. Okay. So the coordinates of n are -2 and 1 because x already is -2 there. And then we just got y equal to -1. Right, so the next thing is now we're going to do 6.5, determine the equation of the tangent to f drawn parallel to G. Okay, the equation of the tangent to f drawn parallel to G. The equation of the tangent to f drawn parallel to G. So a tangent to f that's drawn parallel to G is a tangent to f, so it's going to touch f at one point, but it is parallel to G. So this is the sort of situation we're talking about here. So what do we do now in 6.5? Oh, let's do it. Okay, so now you have that you can find the derivative of this because we are finding the slope of a tangent to the function f. So we must find the derivative. The derivative of x squared becomes 2x. The derivative of -2x becomes -2, -3 is 0, and therefore has derivative 0. Right, so which means that -2x -2, the slope of these is 1. Parallel to g because g has the slope 1. Here is g, show that g is as the equation x plus 1. So g is x plus 1, so it has a gradient of 1. Since g has a gradient of 1, it means that the m is 1. So which means 2x is 3, which means x is 3 over 2. Okay, if that is the case, you got that if this happens, so in other words, the gradient of f is equal to the gradient of what? Of g of f equal to the gradient of g at x equal to 3 over 2. And then now you have this one, f which is 3 over 2, which is 3 over 2. 3 over 2 minus that. And therefore, which is 3 over 2. What is the answer? Is minus 15 over 4. Okay, you do everything, you get minus 15 over 4. Okay, if this is true, we can find the equation of the tangent. Because now you got that the tangent is going to be parallel to G. Parallel to G means you can use any of these formulae. Right, you can use y minus y1 is m into x minus x1. You can use this one to find the equation of a tangent. So y minus, what is the y? So you subtract everything. So you put minus 15 over 4. The slope of the tangent, because it's parallel to G, and G has gradient 1, so you put 1 here, right, into x minus x1. What is x1? It is 3 over 2. So what is the answer? What is the answer? Well, the answer is the following. Is minus 21 over 4. That's the answer. Minus 21 over 4. Minus 21 over 4. Over 4. All right, so that's 6.5. 6.6. For which values of k will f of x and h not intersect? For which values of k will these two functions not intersect? 1 mark. Right, so now you can look at this and think. For which values of k will f and h not intersect? Right, so the couple of things you need to look at here. So you can use any of the results. But if they do not intersect, it really can mean non-real roots. Right, so for 1 mark, it's easy. Right, so you are looking at the two functions, f of x, which equals this one, and g equals that, and h equals that. But the h now is, the tangent is going to have the equation what? It's going to have the equation x minus 21 over 4. So the k in h, right, so the k is what? Minus 21 over 4. The tangent is there. So if you either temper with this one, you temper with this one. If you move it down, they not intersect. So if you can move this straight line down, then it's not going to touch f. It won't touch f. The green one doesn't touch f because we moved the red one down. So how do you say you moved it down? So you say k must be what? K must be less than minus 21 over 4. So if k is less than minus 21 over 4, then it means that you moved it down, and that is answer. You can use non-real roots. Yeah. as well. But it's just 1 mark, so it's not a big deal. Okay, I want us to do some finance now. Question 7. Right, so in question 7, we're going to look at Selby. Selby decided today that he will save 15,000. Selby decided today that he will save 15,000 per quarter over the next 4 years. He will make the first deposit into the savings account in 3 months' time, and he will make his last deposit at the end of 4 years from now. How much will Selby have at the end of 4 years? If interest is earned at 8.8% per annum, and these things are compounded quarterly, which means f is x into 1 plus I to the n. So now x, this guy Selby is depositing 15,000 into 1 plus. Okay, divide by 100, which is 0.088, divided by 4. Over the next 4 years, but it's quarterly. So you must say the 4 years by 4 minus 1. You divide everything by I, which is 0.088 divided by 4. Okay, so we continue and we use our calculators. So we're saying how much will Selby have at the end of the 4 years? So Selby is going to have 283, 283,972, comma, 28 cents. That's what Selby is going to have altogether at the end of the 4 years. But in 7.1.2, if Selby decides to withdraw 100,000 from the account at the end of 3 years from now, he decides to withdraw 100,000 at the end of 3 years from now, how much will he have in the account at the end of 4 years from now? Right, let's look at this. So in 7.1.2, right, so in 7.1.2, Selby decides to take the amount of money 238, 283. So he decides to take the 283,972, comma, 28 minus 100,000. 100,000. 1 plus 0, comma, 0.088 over 4. And you raise it to the power 4, which means A equals. Right. So he withdrew what? If Telby decides to withdraw 100,000 from the account at the end of 3 years from now, okay, how much will he have in the account at the end of 4 years from now? At the end of 4 years from now, this is the amount that's going to be there. And we are subtracting 100,000 that withdraws 3 years from now. So 3 years from now is going to be left with 1 year to the end of this. For 1 year, therefore, it's going to be, you put a 4 here for 1 year. Okay, 1 year. You subtract 1 year. So because it's at the end of the 3 years. So I'm going to look at a timeline to explain this. So that's 174,877, comma 60, comma 60. So we have this. we have exactly that one. Okay, there are many ways to do that, but yeah, that's what. So you can look at a timeline like this and say there's time 0, there's time 1, there's time 2. It's 4 years and we're dealing with quarters. So time 3 is another quarter, and so on. In the end of 4 years, then you're going to have 16 quarters, 15 quarters here. What is it? 14 quarters and so on and more. Right. So then at the end, okay, so in the 4 years, it's going to have 2, 8, 3, 9, 7, 2, comma 28 in the end of the 4 years. But now 3 years would be what? So 3 years from now, it would be obviously a quarter towards the end. So in other words, you're gonna be here. Okay, so this is gonna be 3 years. Okay, because in 3 years, you're gonna be left with um. Okay, just to check that carefully. You need to say 3 years. I'm just trying to use these. So you need to say 3 years. So 3 by 4, it's 12. Right. So 3 by 4 is 12. So this would mean you'd be having 12 quarters. 12 quarters. Right. So 12 quarters. And then now you'll be left with what? Right. So you'll be left with a total of how many quarters? A total of 4 quarters towards the end of the year. Right. So if you're left with a total of 4 quarters, so in other words, you'll be at approximately, yes. So you'll be at T12. So now this is T13, and then this is T12. And then at T12, it's going to be 3 years. Right. Sorry, but yeah. Okay. And then you're going to be left with a total of what? A total of 4 quarters. Total of 4 quarters. Right. So you're going to have that. Just try to think of this. Right. In 7.2, Tsepo takes out a loan, takes out a home loan over 20 years to buy a house that costs 1.5 million. Okay, in 7.2.1, calculate the monthly installment if the interest is charged at 10.5% per annum. And this is compounded monthly. Let's look at that. 7.2. Right, so if Tepo takes out this home loan over 20 years and to buy a house that costs 1.5 million, calculate the monthly installment as the interest charged. So you are dealing with present value, so it is x into 1 minus 1 plus I to the minus n all over I. So this is 1.5 million x into 0, 105 divided by 12. Okay, so it's compounded monthly, so there are 12 months in a year by 20. 12 months in a year by 20. And then it is divided by what? It divided by 0, 105 divided by 12. So which means that x is 14,975 70. So this is it how calculate the monthly installments. So the monthly installments will be exactly 14,972 and 70 cents. 7.2.2. Calculate the outstanding balance immediately after the 444th payment was made. Calculate the outstanding balance immediately after the 144th payment was made. Okay, so we continue. Right, so in 7.2.2, calculate the outstanding balance immediately after the 144th payment was made. So to calculate the balance after the 144th payment was made, the easiest way is to use the present value, which says x into minus n, we divide by I. The present value is 4975, 70. 1 minus which is minus 12 by 8, which is 0,105 divided by 12, which is 969, 969, 927. Okay, so this is it. The present value is going to be exactly this one, which is the outstanding balance, right? But the outstanding balance can also be done differently after the 144th payment was made. Can do it like this, or alternatively, the outstanding balance can be done as saying, so we say that the balance outstanding, the balance outstanding is equal to A minus F. What is A? A is going to be the sort of the final amount. If this is 1.5 million, 1 plus 0,105 divided by 12. And then you have 144. And then you subtract from it 14. 975, 70. 1 plus 0,105. 144. Minus 1. You divide by 0,105. You divide by 12. Right, so the balance outstanding therefore would be 1.5 million multiplied by that. So this is going to be 5259, 229, 61 minus 4289, 302, 47. You multiply everything, and this is 969, 972, is 927, 969, 927, Okay. Right, so this is the outstanding balance, or it is this, or you can use the other approach. Okay, so you are spoiled for choice here. So you can use any of the methods. Okay. Right, the next thing now is we're gonna do calculus. Question 8. Determine f primed from first principles if this is true. Let's look at question 8. Right, so question 8. Right, so in 8.1, the first principles are very easy. So you need to use the first principles formula. So which means f primed of x is the limit as h approaches 0, x plus h minus f of x all over h. F primed is the limit as h tends to 0. Okay, what is f into x plus h? Right, so this is going to be x plus h squared because the function is this one, minus 5. The function f of x is x squared minus 5. But you replace x squared by just x plus h. And then you square it. You divide by h. So this is f primed of x. The limit as h tends to 0, h approaches 0. You square this. This one use the FOIL method. So you square x times h times 2 is 2xh. You square h, you have h squared, you minus 5, you minus x squared, you add 5. You must distribute by the negative. Distribute by the negative. Right, so you have this. Distribute by the negative. Plus 5, and then you divide like this. By h, which means h f primed. Okay. Okay. You have the limit. Okay, you pull out h. H cancels. And then you have f prime of x, which is the limit as h approaches 0 of 2x plus h, and this is 2x. This is exactly what? 2x. So that is the result. Okay, now we have a little bit of derivatives to practice. Let's look at the derivatives, like 8.2.1. You have y equals 3x cubed plus 6x squared plus x minus 4, the derivative, dy dx. Right, 3 by 3 is going to be 9x squared. 2 by 6 is 12x. The derivative of the x is 1. Derivative of minus 4 is 0. We're done with that one. So the next one, look at 8.2.2. Want to find the derivative of yx minus y, which is 2x squared minus 2x. X is not 1. So you pull out this one, which is 2x squared minus 2x. Right, so you divide by the x minus 1. So you have x minus 1. 2x, which is x minus 1, you divide by x minus 1, which is 2x. So if y is 2x, then what is the derivative? What is dy dx? The derivative of the x is 1. So derivative of 2x is just 2. Right. We'll have 2 minutes before the time. We'll have 2 minutes before load shedding happens. And there's no way I can finish this question there's no way I can finish question 9 in 2 minutes. All right. So I think that I'll have to call it a very good evening because my load shedding is just going to happen now at 10. Okay.
Okay.
Yeah. So thanks a lot then. We'll talk, but we'll have to meet again sometime this week. We'll see when. We'll discuss it.
Okay.
Okay. Yeah.
No
Yeah, but
problem.
thanks a lot. Have a good evening. I'm going to post the video when the power comes back. It's going to come back like 12 midnight. So that's when I'm going to
Okay.
post the video. I'm going to send you the link to the video. Okay. Yeah. But thanks a lot. Have a good evening.
Thank you so much, sir.
Okay. Thanks then. Thanks. Goodbye, Waruna.
Bye, sir.
Goodbye. Yes. Goodbye.